Our final speaker of the morning is the Director of Engineering Services at Mars Green Consulting, a company that she founded. From 2014 to 2015, she was mission commander for a NASA-funded 8th-month Mars simulation in Hawaii. And in 2017, she made it to the final 72 candidates in the Canadian astronaut selection process. So please join me in welcoming Martha Lenio.
Thanks. All right. Thank you all for having me here today. I'm here to talk about bright futures in STEM. Futures being plural, there's a lot of different things that you can do with a STEM degree. So we'll touch on a few of those today. And we're going to start basically where you guys kind of are now. In grade 9, you get to high school and people start asking you, what do you want to be when you grow up? Like, how many people actually know right now what they want to be when they grow up? Yeah? Like, that's pretty good. That's pretty good. So, in grade 9, I said, I think I'd like to be an astronaut. And credit to all the people in my life around me at that time. People looked at me and said, I think you could do that. I think if you tried hard, you could actually be an astronaut. And I said, oh, okay. Maybe this is like actually a career path I could follow. So it's not like other degree or other jobs, I guess. Like, there's no set career path to being an astronaut. You don't go to astronaut school. It's not like if you want to be a lawyer, you go to law school. If you want to be a doctor, you go to med school. There's not really an astronaut school. So you could be a fighter pilot. You could go into the military. You could be a doctor and get your medical degree. You could be an electrical engineer, a physicist. So I looked at all the various backgrounds of astronauts that have been selected. And one of the things that came up a lot was engineering, electrical and mechanical engineers. I had no idea what engineering was in high school. There's no engineers really in my family. I don't have anyone kind of in that field. I didn't know what an engineering job really meant. But I thought, hey, it sounds really hard. It uses math and science. If the spaceship breaks in space, I'd like to be able to fix it. So I'll give this maybe mechanical engineering a shot. So I went to the University of Waterloo for my mechanical engineering undergrad. One of the wonderful things about Waterloo is that it has a very unique co-op program. You go to school 4 months, work 4 months, school 4 months, work 4 months. So over the course of your undergrad degree, you've got a chance to try out up to 6 different engineering jobs. Those are the companies that I worked for in undergrad. Bud Automotive, which is a car manufacturing plant that was down in Kitchener. MD Robotics, which is the company that builds the Canadarm for the space station and the shuttles. ComDev, which is in Cambridge, which is a satellite component company. The Forschungszentrum Karlsruhe in Germany, so I got to do materials research at a research institute in Germany for 4 months. Intermodal Engineering is a sustainable building company doing consulting engineering. They started in Kitchener. And Siemens Westinghouse in Hamilton that does gas turbine engines. So I got to try a whole bunch of different types of engineering jobs in different streams of engineering, from research to manufacturing to consulting, and kind of get a feel for what those different jobs meant. During that time, you also got a really awesome opportunity in undergrad to join clubs and get involved in different things that you've never had a chance to before. So I was in the free flight glider team, so you can see on the bottom right there, I joined the free flight glider team in my first year of undergrad. We also started a space club at the university that's still going strong today. So if you go to UW, you could join the Waterloo Space Society. So my friends up in the top right corner there, Melissa Battler, who will come again later, and I started that club. And we would do different things too. There was rocket competitions and the free flight glider competition, but we'd also do astronaut training kind of things. So we did skydiving. So we would take people out to go skydiving. We started ground school training for getting your pilot's license, doing the classes at the university, so it was easier for students to do that if that's something they wanted to do. And then you get to your end of your engineering degree, and I kind of came to a turning point. Okay, I've got my engineering degree now. What do I want to do with my life? It came up again. This question seems to come up about every 4 years or so for me. One of the things that I learned from working in the aerospace industry was that a lot of aerospace companies, while they work on really cool stuff for space, they can also be bidding on defense contracts. So when I was at ConDev, they were bidding on the missile defense contracts. The work, if you're doing like building rockets that go to space, that same type of work can be used on intercontinental ballistic missiles that could bomb another country. So I was like, do I really want to be in this field? Especially when realistically my chances of being an astronaut are very small. Is this what I want my life work to be? Well, you know, there's other ways, again, of becoming an astronaut. I don't need to be an aerospace engineer to build rockets in order to be an astronaut. You could also do, say, something like solar energy. The International Space Station is, you know, powered by solar power. If you go to Mars, you'll probably be powered by solar power on the planet. And that's also something that's really needed on Earth. Global warming is one of the big fights of, you know, our generation. This is the big challenge of our times. I could also be working on solar energy. That's something that's also needed in space, but it's also something that if I don't become an astronaut, and this is my life's work, is making better, more efficient, cheaper solar cells and bringing them out to the world, this is something I can still really feel good about as something I've worked on in my life. So that was a really big part of my decision-making. And then I also took a bit of a detour. Since I was kind of shifting my whole career, you're going to see travel come up a lot. Turns out physics is the same all over the world. Mathematics is the same all over the world. Science is, you know, similar all over the world. So I took 6 months off. I was a volunteer teacher in Ghana, teaching math and science to year 3 and 4 kids there. And this is probably one of the best decisions I've ever made in my entire life. Again, it broadens your perspective. You get to see how other people are living, how the way that we live here in Canada isn't necessarily like the right way to live or the only way to live, and really broadens your mind to the challenges that other people face too. And just the people there were so happy and so welcoming. This was like, I was like, anytime I like smell like diesel and humidity now, like this way it smelled in Ghana, I was like, that was my idea of happiness. I'm like, oh, it smells like happiness here. So this was a wonderful, wonderful experience. And then I came back to Canada and really started to focus on the sustainable engineering aspect of mechanical engineering. So I went back to Intermodal, where I had one of my co-op placements in undergrad. This is one of their projects. This is Okotoks in just near Calgary in Alberta. This is one of the projects they were working on back in 2005 when I was working there. And this subdivision is 90% solar powered, between solar thermal, solar like hot water, and solar electrical. You can see all the solar panels kind of on the garages there. It's a 90% solar powered subdivision. So these are the kind of different engineering challenges that would come across their doorstep and that we get a chance to work on. After about a year at Intermodal, I was like, you know, I've still got this astronaut goal at the back of my mind. And I was like, well, a lot of astronauts also have higher degrees. Maybe I should do a master's or a PhD or something in renewable energy somehow. And which brings us to turning point number 2. So now I had been thinking about the back of my mind, continuing my education. I was looking at schools in Canada, and there was not a lot of compelling research going on in the area of solar power in Canada at that time. One of my sisters finished her undergrad and really wanted to do this working holiday visa thing in Australia. You can get a 1-year visa, work and travel, but none of her friends wanted to go. She didn't really want to go alone, so I thought, you know, I could do a master's in Australia. A master's like 1.5 years. She'll be there a year. And as soon as I looked into schools in Australia, it turns out one of the top research institutes in the world for photovoltaics is in Sydney, Australia. So I went down to Australia. The first time I met my supervisor, he said, you know, you've got good marks, you've got a good resume, you don't need a master's, just do a PhD. And I was like, okay, I want to do a PhD anyways. So I ended up staying in Australia 4 years and doing my PhD in photovoltaic manufacturing, so making solar cells from scratch. So you can see here that these are some photos from my PhD degree down in Australia. It's very, okay, I have a question for you guys. Does anyone know what a diode is? That's okay. I didn't know either. The very first course I went to in Australia for solar, they're like, don't worry about solar cells, they're easy. It's just a diode. And I was like, oh God, I don't know what a diode is. This is some like electrical engineering thing that I've never heard of before in my life. I don't know how diodes work. So there was a bit of a steep learning curve, but I worked at it, I learned it, I took the courses. After about 6 months making solar cells in the lab, I was training other people to also make solar cells. We were making high efficiency devices using cheaper technologies. So one of the ways they make computer chips is like using photolithography. That's the same way that they make all the record-breaking solar cells. So my PhD was on how to make these like high-efficiency solar cell structures, but using cheaper manufacturing methods like inkjet patterning or lasers and metal plating. So you can see one of the test structures in the top left corner, and then in the bottom left corner there is actually doing like the testing, seeing the electronic properties of it, looking for defects using different testing methods. And at UNSW, it was a fantastic experience because you would do all of these steps yourself. As was mentioned by one of the questions, being an international student is quite expensive. And I hadn't really planned on going down there for 4 years. So I was working in the labs, maintaining the equipment, doing a lot of tutoring for classes, marking for classes, coming up with extra ways of supplementing living down there. And because I'd done so much work for the first 3 years, my 4th year down there was a lecturer went on sabbatical, and I was actually offered a full-time teaching position, like basically a professorship almost, lecturer position at the university. So I took on 3 of the project courses and the solar cells and systems course. And one of the fantastic things that I then got involved with was the solar car. I was supervising the students building the university solar car. So 12 students reported to me. I went with them on their race from Darwin down to Adelaide, straight across the middle of Australia. And this is very hard, like it was hard work. I was probably working about 80-hour work weeks, and I was also playing soccer for the university. But it was very, very rewarding. Helping students do their research, helping their projects come to reality, lecturing, it was a fantastic experience. But again, it is expensive. I was offered a job in Silicon Valley before I was finished my PhD, and I worked out a deal that I could get 1 day a week off to work on writing up my PhD, and just work longer hours the rest of the time. And I thought, okay, actually, I'll work closer to a regular work week. I might actually get my PhD done better if I'm not teaching and supervising and working in the lab, 12, 14 hours a day. So I made the decision to go and work in Silicon Valley doing solar cell R&D while also writing up my PhD. So this is one of the labs that I helped set up. I worked for 2 different companies over that time. This is one of the solar cell test structures that I was, again, making new metallization techniques to create higher efficiency, cheaper solar cells so that more people can have them on their homes, workplaces, utility scale, at a more affordable price. This, again, was a really fantastic point in my career. I did some of the best research here. But then things, again, in life happen that make you turn. After 4 years in Silicon Valley, I was starting to think again, at the back of my mind, I still want to be an astronaut. Is this getting me any closer to being an astronaut? I'm also really far from my family, and in 2013, my father very suddenly passed away from a heart attack. At the same time, my mom's mother, my Nana, was not doing so well either. So I had to take a really hard look at my life again, and is this where I want to be right now? It's really hard to make the decision to, quit your job, move back, kind of take a different direction in your career. You kind of feel like you're throwing away 8 years or 10 years of your work. So I kind of got to a pretty low point, but I made my career bucket list. And I thought of all the different things that I'd still wanted to do with my career. And one was still getting a pilot's license, maybe working in Nunavut, doing the Tour d'Afrique, which is a cycling company that specializes in cycling across continents. Maybe I'd like to teach English in a French-speaking country to improve my French. Maybe I'd like to work in Antarctica, get survival training certified. Maybe I'd like to own my own company and be my own boss, set my own projects and hours. Or maybe now it's time to get back into the space industry. So I moved back to Canada. I retrained as a solar installer because there's not a lot of solar manufacturing in Canada. I started my own company doing consulting. And if you remember Melissa, who founded the Space Club with me back in undergrad, around that time she'd posted that this organization called High Seas was looking for candidates to do a Mars simulation mission. So I applied for that. They were looking, the goal of this project is they're looking for astronaut-like candidates. So the NASA can study them. They're going to put us in isolation for 4 months, 8 months, 12 months, and study how our team cohesion, our problem solving, our ability to get through that time. In the idea that they're trying to prepare for a mission to Mars. They want to figure out how you pick a crew and support a crew that can survive these long-duration isolated missions. So I applied. The process took about a year. And there was interviews, there was online aptitude tests, there were group interviews, and then the final thing was a 6-day backpacking trip in the Rocky Mountains in Wyoming. How many of you guys out there go camping or enjoy camping? Awesome. It turns out that is really excellent astronaut training, so you should continue doing that. When I went on this trip, I was like, okay, even if I don't get picked, like this is a 6-day paid camping trip, paid for by NASA, so even if I don't get picked, this is like an awesome opportunity. Over the course of this week-long camping trip, everyone kind of got a chance to be the leader of the group for a day. We were being observed by the National Outdoor Leadership School leaders and by a fellow from the University of Hawaii who was representing NASA. And in our group, there were 3 people. 1 was former military and 2 were current military. 1 was in the Air Force. 1 had been a medical officer in Iraq. And I'd assumed that one of them would end up being the commander of this mission. What I learned from this 6-day course is that the military doesn't actually train people to be leaders. They train people to be really good followers. So when I was sharing like a tent with one of the fellows, he would never really initiate putting up the tent or putting the water on for dinner or anything like that. But if I asked him to, he would do it with a smile. And I was like, oh, wow, this is super weird. And I never had thought of myself as a strong leader up to that point either. I'm more of a kind of like lead from behind, see if people are doing okay, help people who are struggling, and we'll all kind of get to the goal together in the end. What I learned from that experience was that that's a totally valid leadership style. And also for this kind of long duration isolated mission, maybe that's the type of leader that you need. These were all very smart, highly talented, highly motivated people. They don't need me to tell them what they're to do all the time. They're gonna do it and do it far better than I could ever ask of them. So maybe they just needed someone who can like let them go and be their best selves and make sure that we stay on target. So when I was offered the leadership position for this 8-month Mars simulation, I actually accepted it and felt that actually for the, one of the first times I felt I was in a role that I was meant to be in. So you can see on the right there, we were isolated on 8,000 meters or 8,000 feet up Mauna Loa, running off solar power, no internet, for 8 months, living in a dome. If you wanted to go outside, you had to wear a spacesuit, shelf-stable food, the whole deal. And we were the guinea pigs for NASA. They were studying us. Since then, I've also worked for TDA Global Cycling, and I was an assistant tour director for their French Connection tour, cycling from Quebec City down to New Orleans. As stated, I started my own solar consulting company called Mars Green Consulting. Randomly, after doing the solar installation course and recertifying in Canada, all of my projects have been in the north, in the Yukon, Northwest Territories, and Nunavut. So that photo there is from Nunavut in Iqaluit, where there's going to be a hopefully net zero hotel building in the works. As stated, I was also selected for made it to the final 72 of the astronaut selection process. And last year, that involved after a lot of medical checks and background checks, 3.5 days of basically mental and physical boot camp in Montreal. So again, if there are any aspiring astronauts out there, don't neglect your physical activities. It is important. I think one of the major things I didn't get through on was I was one of only 2 people there that couldn't do a pull-up. So turns out upper body strength is important. And I'm also now, in addition to Mars Green Consulting, working for WWF, the World Wildlife Foundation. They have they're a wildlife conservation organization. But one of the biggest threats to wildlife right now is global warming. So one of their overall goals is to get everyone onto renewable energy. I think their goal is 100% renewable energy by 2050. So I'm working on helping Nunavut achieve its, get off diesel. They're 100% diesel right now and move on to renewable energy. So how was that career built? It's kind of all over the place. And I guess I just wanted to show that there's not one right way to go through engineering. There's a lot of different things that you can be doing. You can be doing teaching. You can be anything from the elementary school level up to the university level. You can be doing research. You can be working in consulting. And what you're doing at each point, it depends on what your interests are, your hobbies and goals, whether you feel that industry is socially acceptable from what your worldview is, your family commitments and your social responsibilities to your community. All of those factored into the decisions that I made around my career. And at the end of the day, there's still a possibility they're going to do another call for astronauts in 4 years. So that's still, again, one of the things I'm working for in the back of my mind. So maybe the next thing will be getting a pilot's license or improving my French, but that's all part of the process as well. So thank you all for having me here today. Yeah. Yeah.
We do have time for maybe a quick question, if there is one. Yes, and actually, while we're just waiting, we can have the mentors maybe head out to set up for our next session. Thanks. Well, I believe also that you're going to be around in the speed mentoring session, so if there are questions, because in the interest of time, maybe you'll be around to have people come up. It's quite the journey that you were on, so I'm sure there's lots of questions. Thank you so much, Martha. That was a lovely talk. If we could give Martha, thank you again. Thank you. So we've covered a lot of territory today. We've heard from so many diverse speakers. Also, I wanted to acknowledge our online audience. Thank you for joining us today. We hope you enjoyed the session. Both for those that are here in-house and for those who are online, feel free to tweet or post about your favorite moments from our sessions today, either using @Perimeter on Twitter or PI Outreach on Facebook. We're now going to conclude our formal component of our conference, so please join me again in thanking all of our speakers and panelists for sharing their experiences today.